Wow, you all got up early to be here. I really appreciate that. I have to just redo my timing. Yes, now I'm finished. So all the slides broke, right? Just before I had to present, but now they are working, I hope, and otherwise we'll fix it. And I know the story by heart. I did it a lot of times already. So very awesome to be here. We already traveled around the city and we saw everything. I don't know if you're all from Stockholm. Who is from Stockholm? Oh, wow. So it's a really local crowd. That's an awesome job from the conference organizers. Well, let's take it away. I'm going to talk about security, and I hope you really like it. I'll be around all day to ask questions. Um, so, September 2017, cyber criminals accessed the personal data of almost 150 million users. 209,000 credit card credentials were stolen from Equifax. That is horrible. That's a lot of data. And in the end, they ended up having to pay 300 million in fines to the people who had compromised data, and also 275 million in fines to the government. That's a kind of an odd division. But anyway, this is horrible. And what happened is, if you look, it would be nice if my next slide opens. Yes. It was not something really fancy that the hackers did. It was like an open invitation. Because what could happen was you could use forced browsing as an attack, which basically means that you require information from the backend without using the front end, because it simply was not exposed by the web application, but the resources were exposed by the backend. And there was a vulnerability that was already delivered in March 2017 by Apache Struts, which was mentioned as a vulnerability which was critical and that should be patched right away on the same day. They even got phone calls about this, and they did not patch their vulnerability. And that was the vulnerability that was exposed here. You could also type admin as a user and admin as a password to log in to the employee portal. So it just doesn't stop, because once the hackers found out, well, there was also HTTP instead of HTTPS. Then they started tweeting at a certain moment about the breach they had. And in their tweets, they had links to phishing sites instead of the news site. And then a lot of alerts that were already given by security researchers in March, but also in months after, by HackerOne, for instance, who do a lot of security research, they were ignored. Emails were not answered. And it also took them 30 days after they found the breach to notify the people who were vulnerable with their data, because the top C-level people were selling their shares before they made the notification. That is horrible. And I don't think that everybody has a setup that is as horrible as this. But I think that in software, there's a lot of people who have a setup that is kind of similar. And that is really scary, because if you mentioned it all in a summary, you think, I really do not want to work at a company that treats people's data in this way. But we do. And when I got to think of it, we were in Sri Lanka in November, Sander and me, my boyfriend, and we were climbing this rock. And what I noticed was we obviously took this stairs, right? Because it's safe. But the people back then used this stairs. And I thought, wow, I would be super scared if I would climb those stairs, because it was really windy and stuff. It was high. And what happens is what you feel when you climb these stairs. Even when I was climbing these stairs and just imagining climbing the other ones, I felt fear. And fear is a way to keep you safe. So all your nerves, when you climb a high rock, which is really dangerous, will help you protect yourself. They will help you not to just step on the stairs blindly or blindfolded, because you won't feel like that's a good thing to do. Fear will just paralyze you and stop you from doing things that are dangerous. And the thing is, with digital information, in the digital era where we are living in, if you are delivering software, has anybody ever experienced that kind of fear? Physical fear. Like, wow, I'm committing code and it might be that this leads to a data breach. You don't feel fear. So fear will not keep you safe. And that is why this tweet perfectly summarizes it for me. Software culture does not understand prevention because we don't feel it. We have to rationalize all the things that will keep us safe. And that is far more difficult to do. And then it is getting worse because security is changing. we used to live in an era where security could be handled, but it has changed rigorously and it will never change back. And I will tell you why. So first of all, we have all heard something about Agile. It's a thing, it won't go away again. And with Agile, a lot of focus moved to speed and also nothing else. So there's a lot of companies who have new solutions, and those solutions are not really mature. It's not like they've been on the market for 30 years and thoroughly tested. But we have to adopt them into the heart of our systems because all the competitors are doing this. And we won't keep up pace. And we will run out of business if we don't keep up pace. So everybody is talking about, can we deliver value early? And then somehow the early got the most important part of that sentence. While it was also about value. And value is also about mitigating risk and allowing costs to be okay. But somehow everybody is about the sprint. Sprint also tells you already in your mind, like, I have to be fast. It's not a marathon, but it should be a marathon because we have to have a sustainable pace and nobody can sprint forever. And product owners who got into the lead of software development, they have a bias towards customer value. They underestimate the risk on the part of security in general. And I don't say that's true for everybody, but it is in general. They have a bias because they are focused on the product. And that is mostly seen as customer value. And of course, there's a lot of new languages emerging. If you see the speed of change, I think that nobody here is doing the same frameworks and setups and libraries and languages as 5 years ago. And all these new languages are evolving very fast, and that changes also the way we understand where are their vulnerabilities, what design things should we do and should we not do. So that's already very different. And then on top of Agile came continuous delivery, which delivered us constant change. And of course, a daily deployment is very awesome if you look at how exploratory you can deliver your software. But exploratory should not also be unsafe. It does not mean like, yeah, we were just testing something, so yeah, we kind of gave away our customers' data, but it was only a test. That's not okay, right? So when you deliver software to production every day, it is really hard to keep the same lock on the door as that you did when you delivered software once every half year or once every year. It is changed. So, for instance, there was PayPal, which came into the news in the beginning of the year, about 8th of January. And PayPal had a hacker, which was they were lucky, they had a white hat hacker. And they found that it had a critical vulnerability where you could retrieve the user's data and passwords and also their credit card details on PayPal. That's used very widespread, right? So the hacker collected a bounty of 15,000 euros, about something like that, and then wrote the story. How did he do this? And in his story, well, what he said was, you're bound to find something new, especially if the code you are testing has been in continuous development for a while. And I think that's really true, because what happened with PayPal is they had a perfectly working login system. And then at a certain point, they were experiencing a lot of brute force attacks. And one of those brute force attacks got them into the point like, okay, we're going to use a reCAPTCHA procedure to make sure that we are protected against this. So they included that in continuous delivery. And then a bit later, they adapted a service which was also used by this reCAPTCHA procedure. And then those changes together made that there was data exposed to the front end that was never documented or designed anywhere. So nobody knew it was there, but it was. It's the gradual change that made these vulnerabilities realistic. While with a pen test, if you would go to production every half year, the pen test will probably find that this is not okay. But with gradual change, that is really hard to do. You can't pen test every day if you go to production every day. Then after this, everything is also now connected into the heart of your business, which is really different. So IT used to be mostly exposed within your company. There was no internet. That's a long time ago. But anyway, what you see is that now the depth in which IT is penetrating your business is so deep. So any vulnerability will also run really deep. And this is only going to get worse, of course, because automation is going further and further, and it's taking over the world. Software is eating the world. So that means that also security has a deeper penetration, has a deeper impact on your company. And IT is everywhere. So IT is now also connected not only to our computer, but also to our phones, and also to our smartwatches and all our devices in the kitchen and our Google Home and Alexa and everything. So it is really everywhere. And IoT, I think that 85% still has the default password. So customers are also not protecting themselves, and we have to help them protect themselves. So we have to be resistant, even if they are not changing their passwords. So that's also really different. So systems are really open right now. They have a lot of entry points, and we need to make sure that we protect all those entry points. There's not a single door. Also, teams are getting really autonomous. So where it used to be that there was a central architect who would oversee everything and make every design decision and would also think, yes, this is a vulnerability, we're going to patch this, and have some company-wide project to make sure that we are patching it. That is no more. You are responsible for your own product. And knowledge about security is now distributed over every team instead of one single authority that nobody ever understood, but they said very smart things, right? So, and now you have to handle those things yourself. And that's really a lot harder. So we see changing roles. People do new things and they are experimenting every day to see, like, can I get this working? I don't really understand it yet, but I do want to try it because it thinks it will help me on my journey. And all those experiments, we don't do that with a full scope, like how will this impact the whole system? So altogether, I'm convinced that we really need to do things differently. We need to rigorously change the way we are doing security. So we are moving to security in an agile world. And when I thought, okay, so how are we going to do this security in an agile world? Well, let's see. Security, in my opinion, should deliver the value. Should deliver. It should support the delivery of value. Wow, it's really hard to read a sentence. It should not stop value. It should not be that people are trying to push out things, value to customers, and that security is always saying, no, this is not okay, trying to fix every possible vulnerability. Because the purpose of writing software is actually to deliver it to the customer. So it can't be that security is only stopping this process. It should support it. And I really like this picture. Everybody seemed to like this representation. And this is how it feels when you are in security. You're cleaning up other people's shit. And that's not the way you should work together with colleagues. This is not how it should be. So if you're doing DevOps without security, you're doing it wrong. And that's something that everybody should take home. This is the one message that I really would like you to take home. So I thought, okay, let's do it differently. And I developed a model, which I hope will inspire you how to do things like security in an agile world. But first, I'm going to introduce myself. I'm Kim. You already knew that from the brochure. And I had my Hello World in 1980. I have been in IT for a lot of years, mostly in CIO and managerial roles. And then at a certain point, I just stopped believing in the concept of management in software development, because I think that you cannot have like a single point of knowledge and content where everybody should go through and to have their decision made, because software development has become way too complex for anybody to oversee. So, and there are a lot of knowledgeable people. So I really believe that that is where the decisions should be made and where the mandate lies and where the freedom should be, which was a problem because when I stopped believing it, I could not be a manager if I did not believe in the concept, right? So I had to change jobs. And now I found this really awesome job, and the title is called a customer director. But I'm really part of the team, and I'm the one who would be more focused on the overview and make sure that we are still all together heading in one direction, which is really different than a manager because I don't do any appraisals or whatever. I'm just really part of the team. And I'm really happy. The company is Schuberg Phillips. It is an IT outsourcing company, so we manage the IT of a big company. So we have 300 people and only 20 customers. So they're all big customers like banks, energy providers, governmental agencies like the Ministry of Finance. If one of those goes down, it will hit the news. And we manage those environments, which we call mission critical environments. We started in 2001, and I think we have a single KPI, and that is 100% customer satisfaction. So when the company started, the founders already said, we are not going to have managers. We have one KPI, satisfaction. Everybody should be focused on that and should do everything they think is necessary to achieve that. And it's really cool to be there. So as I said, our companies are banks like ING, you probably know, and Rabobank. This is a big supermarket, KLM, probably familiar. So that's cool. And we are, I think, really proud because this is a survey about how people perceive us, like how many fans do we have and how proactive do they think we are. And these are all the other outsourcing companies, and that's us. So that's cool. Enough about the company. Let's get back to the model. So how did I get into security? Well, basically, I'm not an expert. I hope I don't disappoint you. I think at a certain point, I was working at the previous company, and then we were having this idea like, oh, every of our 1,000 customers has this on-premise installation where they run their customers. And then we thought, we can really save them money if we put them on AWS and we manage that environment, because they don't need people to manage their own environments anymore. So we thought, well, that's a nice idea. We did a transformation to AWS, and we were about to load all the customers' data, the customers' data, into our systems. And then I was thinking like, okay, so we never handled infrastructure up until now because that was our customer's job. And we are now combining the customer data of all our customers, which is about every citizen in Holland would be in there, given a market share of 80%. And I thought, wow, is this really a good idea to expose this on the internet, not really knowing what we're doing? And then I thought, okay, let's try to do more about security. And I went on to a journey with a group of people. We were with 9 with a little satellite team, and it was like a cool story where we learned a lot of things and also fell on our faces a lot of times. And I hope to share that with you. So first of all, we learned that there is something like secure coding. And basically, the idea is very simple. If you are in an agile world and if you have continuous delivery, you need to automate everything because you don't have time to do a manual pen test, just as that you don't have time to do a manual test. And then you have to just figure out how. And there is a bunch of tools. So first of all, there is a SAST, which is a static analysis security testing tool. And those tools are pretty awesome because they will find vulnerabilities very early in your life cycle. Maybe even while you are writing a single line of code, it will give you immediate feedback, just like any other static analysis tool will give you that, like linting. So we use SonarQube, which is probably something you are familiar with, but it has a separate rule set, and you actually have to make sure that it runs because by default it's off. So getting this when you already have SonarQube, it means that you only have to go to the config files and hit the checkbox. That's easy. And then it will probably result into like thousands of vulnerabilities because that's what it did for us when we first put it on. So it will give you very detailed feedback, like this line of code has this vulnerability, possibly. But it also has the problem that it has a limited scope because reading every line of code and assessing it is not the same thing as assessing it runtime. So it has a lot of false positives and a lot of false negatives. So what we do is we have kind of an override system that will say, yes, we already know this vulnerability. We mark it as not valid in our setup. So you do have to do a little bit more because otherwise you get the same vulnerabilities every time you commit your code, and you don't want that. Because then the real vulnerabilities get overlooked into the whole 800 vulnerabilities that are reported every time and are not valid. So it is good, but it has a limited scope. On top of your SAST, you can use a DUST, which is a dynamic analysis security testing tool. And this will test your application at runtime. So it is a realistic view. It is how any hacker would try to enter your system. So that's good. But the problem is you need to have a running instance. So it's a bit slower. It will not give you immediate feedback. It will not allow you to shift left as much as you can with a SAST. So it's really okay to use both, advised to use both. They are also harder to track. So when you find a SQL injection vulnerability in your solution, well, you have to find out where it is. And those tools will help you a bit, but you have to find out yourself. You have to know the system and understand the system, which you have to do to write software anyway, so that's okay. And we are using several solutions within our company, Nessus, Sentinel, and Zep. So we have a lot of customer teams, and every customer team decides for themselves. As I said, there's a lot of mandate and freedom. So we did not have one, we have three. And they all have their strengths and weaknesses. I also included some links, the slides are posted. Where you can see that there is the OWASP project, and they do an assessment of every security testing tool, the SASTs and the DUSTs, and you can find an index number how strong they are perceived by OWASP. And there's a lot of people contributing, so that's excellent information. If you don't have any of these solutions running, look into that score before you choose one, because it's not the company brochure, it's an objective measurement. ZAP is the OWASP project. Probably most of you are familiar with this. It can do a lot of things except not only Dust. So that's just one part. The good thing is you can do a lot of things with it, so it can deliver a lot of value, but it also gets more complex by this, because it just is like you get lost when you start with it. So if you start, I would not advise it personally, because we kind of lost track in it. And these things are more fit for purpose if you just want to learn how to do this, if you're taking your first steps. So next up, you have to do your vulnerability assessment. So there are libraries in the code everywhere, right? And those libraries are also written by people, and they also contain vulnerabilities. So you need to know which vulnerabilities are in which libraries, and also you need to fix them. Just like the Apache struts in the Equifax had a vulnerability, which in the end was exploited. So the dependency checker, there is a very important distinction. Do not run this in your pipelines. The SAST and the DUST, you can run them in the pipelines, because when you change something, you want to know that the change is still safe. But the vulnerabilities in your libraries, you can have a library which was green when you build it and when you ran the pipeline, but it can be just there in production, and then the vulnerability is found. So you do not need to run it on change, you need to run it on run. You need to just run it on your whole code all the time. It's a very different solution, and it's wrongly implemented everywhere. We have JFrog X-Ray. We run it once per week, because if you run it once per week or more often, you only get the Delta files, so it will be a lot faster than when you have to do a full reassessment. So if you run it once per month, you will miss something, and also you are at risk. So how does it work? A company that has a library will report a vulnerability into their central vulnerability database, or the global central vulnerability database. This vulnerability, from that moment, is known by everybody. So the risk goes up from the moment it's reported. And then from that moment, there is not even a patch. So then you can have a 0-day attack. It's reported, there's no patch available. I think in the last week we saw a lot of vulnerabilities with Citrix and with Windows. There were critical updates, and those were very similar to how this system works. Windows and Citrix mention their vulnerabilities, and the whole world panics from that moment on until the fix is there, and then there's rest again. So you need to know when you have a vulnerability, and you also need to fix them. To be able to fix them fast, you should not be 100 versions behind, because probably your code will break. So it also means that you have to have a good patching culture, where you will install every patch all the time. Otherwise, then you know the vulnerability, but you just can't do something about it. You can just sit there and watch until the people hit you. So other options are Sonatype. The OWASP dependency checker we used at our previous company was also an excellent tool, because it was included in Sonar. So if you want to make a very quick step, you already have SonarQube, then just checkbox the OWASP dependency checker and you're done. And there's also SAML, which is a variance analysis. That is really cool tool. It will go into GitHub. So a variant analysis will say there is a vulnerability known and mentioned by a company, and now it will try to do little changes on this vulnerability to try to see if there is a vulnerability with a similar pattern. So it uses artificial intelligence on top of known vulnerabilities. I think that is where the world is going, because otherwise you're always only looking backwards instead of adapting forward. So that is cool. I did not experience with it. It's high on my bucket list. Next there is something that's called a licensing threat assessment. And basically that means when you are using a library, it might be an open source library. And some open source libraries have the obligation that if you use them, you must get open sourced yourself. And when you're at a commercial company, you don't want that. It might not be able in the competitive landscape that you have, right? And then the bad thing is, if it is the library that you're using, you probably can see what are their terms, but those libraries are using libraries, which are using libraries, which are using libraries. So it goes really deep. You cannot assess all the libraries that are in the libraries. Well, you can if you automate it. So there are modules to do this, a licensing threat assessment. They will tell you if there is a license structure anywhere in all the depths of your code that you should not adopt into your code given your own policy. So you can also look into this. We were running this also in Sonar. Sonar is pretty rich. And it also works if you include it at least. What we also did is we have some evil user stories running, and evil user stories are just like user stories, but now from the perspective of a hacker. So one of those user stories, for example, is as a malicious hacker, I want to gain access to all repositories so that I can look for vulnerabilities and secrets and destroy their entire business. And this test will see, is it possible to get access to the repositories? So that if somebody by accident exposes a repository as public that should not be public, this test will run green, red. I think red. It's a negative test. I'm not sure. But it will say, okay, stop. There is a mistake in the configuration of Git or whatever you're using for your repositories. And that's pretty cool. It will help you keep your infrastructure safe. Next is, on top of secure coding, you also need to have a very defensible infrastructure. So I'm not going to go at length on how to protect your infrastructure, because I think that's not always relevant for the people in this room. But there are some changes that are really part of the DevOps team. So I'm going to focus on those things, because they probably are in your own environment. First of all, there is something as a immutable infrastructure. And not everybody is working in an immutable infrastructure, because it probably will require some deep redesign of your systems. If you're there, you're lucky, but not everybody is. But you can adopt at least the mindset that comes with an immutable infrastructure, because there are some elements that you can also do on an on-premise installation, or something that is not immutable, but at least infrastructure as code. So what happens when you have an immutable infrastructure is, immutable means it cannot be changed. And there comes a lot of protection from things that cannot be changed. So if you are able to kind of adopt this mindset into your applications, that is great. So what you can do if you have an immutable infrastructure is, all the infra is code. So you can scan the infrastructure, the code, for vulnerabilities. And this is something where I think that we kind of still work in silos, where development has already learned to scan for vulnerabilities, but where the infrastructure is still working in a very different way. So where software developers can add value to their infrastructure colleagues. So when you have code to run the infrastructure, I don't mean scanning the infrastructure itself, but scanning the code for vulnerabilities. And you can actually teach the colleagues from operations how to do that. There's also the configuration and patches. Those are code changes, and they should follow the pipelines. So what I see is that every software change has a peer review, has a lot of tests, and in the end, when all is green, it goes to production. And that patches still totally follow a different route where somebody installs them, does some manual checks on development, test, acceptance, and in the end uses them in production. Why do we not run real unit tests on a patch? Because we can. So consider them as code changes and let them follow the same pipelines as we do for any other change. There's no reason not to do that, except that we are not accustomed to it. You can apply least privilege principles. So that means if you have an immutable infrastructure, there is no reason for any root account or admin account on your infrastructure anymore, because they're not supposed to change anything. And every change should be rolled out through your pipelines. And any change, if you can roll back very fast, there is really no reason to log into your system anymore. So you can delete the root account, which it sounds really scary, but the front runners on security are doing this. And that imagine the safety that comes with not having an admin account. You can apply pervasive visibility, which is funny when my slides go away. I'm sorry for this. I hope it works again. Yes, cool. Okay. So the last thing is you can have some systematic workload reprovisioning. And that is a difficult sentence, which I had to read for 4 times. But it means actually, if you have an immutable infrastructure, you probably have multiple instances running of your infrastructure already to be scalable and also to have a failover system. So what you can do is you can just randomly take one down, which will allow you, first of all, to see if the failovers keep working, which is already good to do. But on top of this, if a hacker would have access to one of those resources and they had their difficult way into the system, and then you randomly reboot an instance, it is really hard to survive that as an attacker. So it gets so complex that a hacker will go to another party because, well, you already have no privilege and then you are thrown out every time. Yeah, that doesn't sound like fun anymore. What we also do is we are testing the infrastructure. So there are the Center of Internet Security has best practices on how your infrastructure should be configured. And as I said, there's a lot of times where the infrastructure will be deployed, and at that moment it will be assessed against these best practices, but it will change through time because of continuous delivery, because of changing requirements. So what we have is we have a constant scan running every infrastructure instance against these best practices of SIS. And we also have the deviations registered in a configuration file. So every time that you want to deploy an infrastructure element and it is not it does not comply to the best practices, it will alert you. It will stop you from pushing it out to production. What happens then is if you say, but this instance really needs to have an admin account, and I have a good reason for it, because the real world always has to allow you to take shortcuts, right? It is always kind of like that because you are in a hurry or something. So what we do is you can then send a pull request to somebody of the security team and allowing this deviation for the moment. And then the person from the security team will see how big is the risk and will either approve or not approve it. And that means that the deviation from the best practice is specifically four-eyed by a person from the security team. So I think this is a really safe setup to run your software. It also will just prevent mistakes, because those are the things that run in our code most of the time. On top of this, we also have a CDN, which is a content delivery network. And there are a lot of providers. We use Akamai that have, from their position as a content deliverer, also learned a lot about security. So Akamai is now, in my opinion, the #1 provider for protection against DDoS attacks and SQL injections and things like that, because they are at the edge where all the traffic is hit. And they are the ones that are exposed when there is a DDoS attack, not the one who delivers the content, because the content deliverer will have the traffic, and a lot of the traffic is cached in their memory. So The customer does not notice it. So they have to protect themselves. And they do so on a global scale. That means that the amount of knowledge they have gathered about a DDoS attack or a really distributed DDoS attack, which is really hard to find, well, they are crazily good at that. Also against SQL injections and cross-site scripting. So what you can do is when you put a solution like that in front of your code, it's just like you don't build your own version controlling system, right? So you just use somebody else's knowledge on how to do this. And it's the same with this. You can, of course, and you should protect yourself against DDoS and those kind of attacks in all the OWASP top 10, but they just have a lot of knowledge. So use a solution that actually allows you to use this knowledge, because that's an easy way to grow. So it's not only about the automation. You also need to have a way of working that will support the delivery of safe software. First of all, I think it's a really good idea to have security champions. So I always think like the metaphor when I put things on the stairs, and I have 2 kids. My kids are 14 and 15. And I've told them 100 times, when you walk up the stairs, take the bag with you that is lying there. And they never do that. How come? Because it is a shared responsibility. Everybody is responsible for taking the bags up, and nobody does it. And it's the same with working in a team and where everybody is responsible for security. The problem is also everybody is responsible for team dynamics and for speed and for good designs and for architecture and for innovation. So if you're responsible for everything, are you giving security enough love? And that also goes for all the other topics. So it's good to focus. It's good to have something that's yours. So security champions will just be the group of people that is focused on security more. And that will take the group of people, the team, by the hand and allow it to grow in security. It does not mean that this is the one person who like the horse picture, cleans up all the shit of the team. Security is everybody's responsibility. It's just that it's the focus of the security champions. So, and how do you find them is a question I always hear. Just ask who's interested, because passion is the start of a lot of development. So don't appoint somebody. Security can really be fun. Don't eliminate all the risk. So just like you don't want to deliver all the value that the customer wants, because that is too much. It's not worth the money. You don't also want to test everything, because that's too much. It costs a lot of money. You don't deliver mitigation for all the risks. It's just too expensive. So you have to do a risk assessment and see, is this really important to work on? If it isn't, don't do it. You have a backlog of security features just as of functional features and technical features. Make sure that you have alignment of security and business value. So what you don't want is that security becomes the #1 priority. So yes, this can be secure in a way. Nothing can happen inside the toilets that you don't want to. But it's also exposing a lot of privacy, which you don't want. So it has to be balanced. You also have to learn and adapt first before you break the build. So what you don't want is that you go home and you think, oh, wow, that's cool. I'm going to put the checkboxes in SonarQube on. Now I have a SAST and a Dust running and a dependency checker. And then I'm going to stop people from committing code that is not safe. Well, people will hate you for that, and they will never love you again. So don't make people do that. Make sure that you explain things. You can choose the rule set that is run, for instance. So if you have instantly thousands of vulnerabilities, people will ignore them. It feels like a mountain that they can't climb. So just make sure that you just put on one rule and say, wow, I want us to look at this rule, make sure that our code complies. And then you grow security. It's far better to do it that way. And also not break the code, just have a warning, sit next to those people and explain them why it is a vulnerability. Because mostly it starts with not understanding. So if you explain it, they will regulate this instead of being regulated by a pipeline. And that's far more okay. Don't forget, yes, you can have a scanner, but having a scanner does not make you any safer. You just know where you are unsafe. Fixing the vulnerabilities will make you safe. It sounds like a real open door. And still, I hear and see it everywhere when I talk to people. Yes, we have a lot of scanners, but we never look at the results. So if you are in that position, make sure that you adapt the rule set. diminish the amount of rules that is looked at, but make sure that the ones that are on are really fixed, because that will actually make you safer instead of only on paper. Yes, we are doing some vulnerability scanning. That does not make you any safer, right? Identify and remove, start small. So as I said, just adapt the rule set. Make sure that you start with something that is important in your context, that is helping people to learn and grow, and don't just throw it over them. Lastly, I also want to say there's something like situational awareness. So as I said, there's a balance between business value and security, and you need to know where the balance is, but it's really hard to choose, right? Mostly there comes like a big model where you have to do 20,000 checkboxes, and in the end there will roll out a value that you don't understand anymore even. So I don't think that's the way we should do security, because it's really an abstract way. So there is something like situational awareness. You have to know what to use when, and in what context is this a good idea, and in what context it is not required and it only costs you a lot of money. So first of all, as I said, there in an agile world, you need to automate everything, and please start doing that. So features and scans against bugs and vulnerabilities. You don't want to have a kid that goes into the dark web and has a script that is ready to run. You can literally push a button there, and then it will attack your site. You don't want to be vulnerable against those kind of attacks, because it feels like you have an immature tool when you're vulnerable against this. But it won't keep you safe with this alone, because you also need to check for logical flaws manually. You also need to educate and raise context awareness. So for instance, we moved from a monolithical system to a microservice system. And in a microservice system, you have a lot of RESTful APIs, or at least we had. And what happens is that anybody can use them, right? And given the context of that moment, somebody will see, is there data in this API that I'm calling that should not be exposed? And at that moment, no, it isn't. And then what can happen is that somebody adapts the service, and now the social security number is added. Because of non-breaking services, it will probably accept the input anyway. JSON is very reluctant, very free to change, right? So in the front end, now the social security number is exposed. That's a logical flaw. So not knowing what is changed where, and then having the social security number visible in the response object in your console is not okay. Those things need to be checked manually, because you cannot protect yourself. Sometimes it's meant to expose this piece of data to your front end, right? If it's the employee portal. So you need to have people aware. How do you do that? Well, training. This is nothing new. This has always been there. What does happen? Of course, you have some security training. Make sure it's small. Make sure that people can understand this. I have to watch the time, because now my timer restarted when I rebooted the slides. So I have no clue. Nice. So that's the first part. Make sure that you have some training, and it's good if it's low barrier, that you have something in company where people just teach each other. So what we have, for instance, is that one person from the team just does some research against a certain security issue, and then educates the rest of the team. So that's a way to also get this get the mandate in the team and keep it there. But you also need to have something like contextual awareness. This is an example of an app for your phone that you could buy and sell weed with. It was running in Israel. And the people who made this app thought it was a good idea for the safety of the sellers and the buyers to have a strong identification through a passport. Yes, this always happens. People start laughing like, how did you get to that idea and also put it into production? That is contextual awareness. This is the example. Think about, is this a good idea anyway? And don't overestimate the amount of protection you can bring, because of course the police hacked into this system and they gathered the data for 9 months, and then everybody who used this, about 300 people, went to jail. Yes, that happened. Of course, you could see that coming. Right? Don't do those things that you see coming, that you think, I'm not safer than the police, right? I'm not stronger. Don't overestimate yourself. So what we do is we have this security upfront list, and still it's a bit lengthy. But what we do is when we really start using, especially for SaaS services, we have a few questions like, is this a good idea? Are we able to work with this SaaS service given what we are asking from the safety, the privacy, the availability, which is also part of security. And if it's not, don't hope that they will adapt their systems, because that has a dependency which will make you vulnerable. You do not have control over their roadmap. So then just look for an alternative. There's enough. What we also do is, chaos engineering, make rare things regular. What could happen when the power goes off? You want to make sure that your failover to your offsite location works. So you just sometimes put the power plug, you just switch it, right? You can do the same thing with security, and then it's called security chaos engineering. So what we did, for instance, was a hack yourself first or hack yourself two. We started calling it after a while because we assumed we were already hacked. So what we did is there would be a monthly day where there was pizza and beer, and we try to hack into each other's systems. The cool thing is that it is a great team building event because you really learn about other people's solutions, other team solutions, which mostly otherwise you don't. You just watch the demo and then go back to your work. And this is a different way of interfacing with it. And what also happened is that instead of people thinking like, oh, this is probably safe enough, nobody will notice. Well, they knew, like, yes, end of the month, my colleagues are going to notice this. So you make rare events regular. Security attacks just don't happen often enough. And in this way, you make them very often because they happen once a month. What you can also do if you want a different form is have a hackathon, make teams, and say, okay, the first one who can hack into either one of our systems wins a prize. Those are fun elements, are team building elements. People will learn a lot about security by trying to attack it instead of trying to defend it. Because Troy Hunt, which is one of the main security researchers in the world, he said, thinking as an offender will show you the real threats of your applications and grow awareness from finding out how easy it is. And it is. So if you, for the first time in that session, when we found out how easy it was to do some cross-site scripting, it always felt so crazily complex, and it isn't once you start learning how to do that. And that will help you to defend your own systems, much more than only learning how to defend them. What we also did is red teaming. So we hired a company, and that's called red teaming, who will try to social engineer us. So they will try to walk in with a ladder and say, please keep the door open, and try to attack us in that way. And they said, for every company that we cannot penetrate in any way, so we try calling them, we try to get them give us data, we try to get into the building without authority and stuff like that. And when it is not possible, that company sends a cake to the company. So we are really proud because we got the cake, and that's really nice because we do really keep the doors closed, and we have a very strict locking policy. We sheep everybody who does not lock their computer. So if the person besides you walks with a phone and has a phone call, you send a sheep picture to the whole company, and that really does something with awareness, right? When you start working for the company, everybody, the first thing you get is not your laptop. You first get a security training. That does something to the mindset of people. Like, how are you supposed to handle security on your laptop? Because we have the full mandate to do everything. We have no restrictions. We can download anything, but we are supposed to be aware of what we're doing, right? So we start with a security bootcamp, explaining us where the dangers are, explaining us if we have questions where to go. And that's a really strong thing to go about. And what I also really liked about it is that the picture of the cake got sent around, and then instantly, within a minute, somebody replied, like, did you check the cake for hard and sharp objects before bringing this inside? And I think that is really what a strong security mindset is about. It's everywhere and it's constant. And if you can reach that within your teams, I think you're doing a great job. So wrapping it up, there is something called secure coding, which will allow you to automatically check your code for vulnerabilities through a SAST, a dependency checker, through a licensing threat assessment and evil user stories. You have to have a defensible infrastructure with config as code immutability, test against the sysconfig files, and also have consider to use a CDN and a SIEM solution, SIEM for your visibility. You have to have situational awareness. You can train people, raise awareness, hack yourself first, and do red teaming. And you have to have a supporting way of working with a sec lead and security satellite team that has responsibility assigned in the teams. Make sure it's value based. Start small. Adapt to the context. Fix issues. Detect change. Have version control and everything. And that's it. If you want to see the slides, you can use the QR code. It does not link you to a malicious site. Thank you for being here. That's it.